We talked about before in the previous video about Grignard reagents and that reaction with aldehydes and ketones, but Grignard are very strong bases in strong nucleophiles and are capable of reacting with other compounds such as esters, carboxylic acids, and more. I'm going to show now what is the mechanism for that when it's reacting with ester. In the case of esters, we're going to have an excess of the Grignard reagent, and we're going to see in a minute why is that. So let's draw the structure of an ester and say that it's just a general ester. If we have that, again, the carbonyl carbon is electrophilic, so you will have the nucleophilic attack. And then you will form this intermediate similar to the alkoxide that we did before. I think I need to use another color here. So that. So now here you have two carbons. Remember, we're adding that fragment. And here you have the other part of an ester. So typically in the mechanism, what happens is that the carbonyl reforms and this goes out. So that is, say, loss of leaving group. And typically this group is a bad leaving group. So you can, but under the conditions that we work with, and particularly because you're forming this compound that has a very strong bond, carbon-oxygen, these will actually exit. So this is loss of a leaving group. But now notice you started here with an ester, and you have one nucleophilic attack over here, the carbonyl carbon. But now you have a ketone, and the ketone can also be attacked. So we can have, say, another molecule of that attacking now over here and have a second nucleophilic attack. And then the product of that reaction, we are going to make an alkoxide. Remember, we're adding a Grignard reagent that has two carbons, so we're adding another ethyl group. And this is the alkoxide that you're making. And you started from a ketone, you're going to make this is tertiary. At the end, you're going to have a tertiary alcohol after the protonation step. So again, what happened in this case is that we needed to use an excess of Grignard reagent because at the first step, you will have the nucleophilic attack over the ester itself. And then with after you form these intermediate, you will have the loss of that leaving group and a second, say, nucleophilic attack. That's why we use an excess to have that alkoxide. And finally, you add water to protonate the alkoxide. So now we're going to be using these reactions working with synthesis problems, planifying synthesis and solving reactions. I'll see you in another video.